The world is electrifying, and so are our roads. The rise of electric vehicles, or EVs, is more than just a trend, it's a revolution. But here's the catch: as we transition to greener transportation, the backbone of this revolution, our power grids, faces immense challenges. Today, I'm inviting you to explore how smart grids can adapt to this EV boom and the innovative solutions paving the way for a more sustainable future. Imagine a world where your car not only takes you places, but also plays a pivotal role in balancing energy demands. That's the promise of integrating EVs with smart grids. A smart grid isn't just an upgraded power grid, it's an intelligent system capable of two-way communication between utilities and consumers, real-time monitoring and decentralized energy management. But marrying EVs with smart grids? That's where things get exciting and, yes, challenging. Let's dive into the hurdles, backed by real-world examples and research findings. First, surging demand. Imagine millions of EVs charging simultaneously. This massive surge in electricity demand could lead to grid instability, blackouts, or expensive infrastructure upgrades. For instance, a 2023 study from the International Energy Agency highlights that uncoordinated charging could increase peak electricity demand by up to 30% in urban areas by 2030. Second, load management. EV charging isn't uniform. Peak demand typically occurs in the evening when most drivers plug in after work. A case study in California showed that evening demand spikes could strain local distribution networks, leading to higher operational costs. Third, bidirectional energy flow. EVs are not just consumers, but can also act as energy sources. Vehicle-to-grid technology enables cars to send unused electricity back to the grid. However, the National Renewable Energy Laboratory reported that implementing V2G requires overcoming regulatory and interoperability barriers. Fourth, infrastructure challenges. Deploying enough charging stations, especially fast chargers, requires substantial investments. According to Bloomberg NEF, the United States alone will need 1.2 million public chargers by 2030, a sharp rise from the current 120,000. Moreover, integrating these stations into the grid without causing localized overloads remains a significant challenge. And finally, cybersecurity risks. As grids get smarter, they also become more vulnerable. A 2022 report by the Cybersecurity and Infrastructure Security Agency warned about potential threats from poorly secured EV chargers, which could serve as entry points for attacks on the larger grid.
Ready to ride the wave of the future? The electric vehicle industry is booming, and now is your chance to get ahead with Riney, Tech Skills and Fundamentals. Introducing our exclusive electric vehicle crash course, taught by the expert Dr. Jignesh Makwana. Learn everything you need to know about EVs, from fundamentals to advanced techniques, all from the comfort of your home. And here's the kicker. For a limited time only, you can grab this course at a special discounted price. But hurry, this offer won't last long. Don't miss out on the opportunity of a lifetime. Investing in this course today means securing your future in the fastest growing field. If you pass on this offer, you're guaranteed to regret it. So, what are you waiting for? Click the link in the description to enroll now and start your journey towards mastering electric vehicles. Remember, the future waits for no one. Riney, Tech Skills and Fundamentals, your gateway to a brighter future.
Despite these challenges, the future isn't bleak. Here's how innovators are turning these hurdles into opportunities with support from leading companies and groundbreaking research initiatives. 1. Smart charging. Picture this: your EV knows the best time to charge based on grid conditions and electricity prices. Smart charging systems optimize charging schedules, reducing peak loads and saving costs. Companies like ChargePoint and InLX are spearheading innovations in dynamic pricing and energy load balancing, making charging more efficient and affordable. 2. Vehicle-to-grid V2G technology. What if your car could power your home during an outage or help stabilize the grid during peak demand? V2G technology makes this possible, transforming EVs into mobile energy storage units. Companies like Nissan, through its Leaf-to-Home program, and Tesla's Powerwall integrations are setting the standard for this revolutionary approach. 3. Renewable energy integration. Charging EVs with renewable energy is a game changer. Solar-powered charging stations and wind energy integration reduce reliance on fossil fuels, making transportation truly green. The European Union's Horizon 2020 projects focus on renewable microgrids that enhance local energy efficiency. 4. Advanced energy management systems. AI and machine learning are at the heart of modern grid management. These technologies predict demand patterns, optimize energy distribution, and prevent overloads. For instance, Siemens is leveraging AI to design predictive grid solutions that ensure seamless EV integration. 5. Investment in grid infrastructure. Governments and utilities worldwide are ramping up investments in grid modernization. Upgrading transformers, deploying energy storage systems, and expanding charging networks are critical steps toward accommodating the EV revolution. The US Department of Energy has launched initiatives like the Grid Modernization Initiative, GMI, to prepare the grid for the EV era. 6. Enhanced cybersecurity measures. With great connectivity comes great responsibility. Strengthening cybersecurity protocols, using blockchain for secure transactions, and ensuring robust data encryption are vital to protect the grid and consumers. The Cybersecurity and Infrastructure Security Agency, CISA, is actively working on securing EV networks and infrastructure from emerging threats. Let's look at how these solutions are being implemented, supported by research and industry initiatives. California's push for V2G. California is leading the way with pilot projects that allow EVs to supply energy back to the grid during peak hours, helping to prevent blackouts. For instance, projects funded by the California Energy Commission demonstrate the scalability of V2G technology. European Union smart charging initiatives. Countries like Norway and the Netherlands are deploying smart charging infrastructure integrated with renewable energy sources. The European Green Deal and Horizon 2020 programs have allocated significant funding to test and deploy these systems. India's microgrid projects. With its growing EV market, India is investing in microgrids to support decentralized and reliable charging infrastructure. Reports from the Ministry of Power highlight partnerships with companies like Tata Power for scaling these solutions. These examples underline the real-world impact of integrating EVs with smart grids, backed by data and ongoing research. Integrating EVs into smart grids isn't just a technical challenge. It's an opportunity to reimagine our energy systems. It's about creating a sustainable, resilient, and intelligent network that benefits everyone. And while the road may be bumpy, the destination is worth the journey. So the next time you plug in your EV, remember, you're not just charging a car, you're driving the future of energy. Together we can make this transition smoother and brighter. Are you curious about the latest advancements in smart grid technology? Or perhaps you're working on a research project in this field. Share your thoughts, challenges, or ideas in the comments below. Let's spark a conversation that drives innovation.